Hello, students, and welcome to the first topic of alternative and renewable energy sources. The topic we will be covering is why renewables. In this first topic, we will go over a few definitions. The main topic is why renewables. A broad statement would be that most renewable energy sources produce little or no global warming emissions. Different sources of energy produce different amounts of heat-trapping gases. Renewable energies tend to have much lower emissions than other sources such as natural gas or coal. Energy is a capacity or power to do work, such as a capacity to move an object of a given mass by the application of force. Energy can exist in a variety of forms, such as electrical, mechanical, chemical, thermal, or nuclear, and can be transformed from one form to another. There is potential energy, energy by virtue of position, kinetic energy, energy by virtue of speed, and so on. A joule is a SI, Systems International, unit of work or energy equal to the work done by a force of 1 meter acting through 1 Newton acting through 1 meter. Renewable energy is energy from a source that is not depleted when used, such as wind or solar power. Non-renewable energy comes from sources that will run out or will not be replenished in our lifetimes, or even in many, many lifetimes. Most non-renewable energy sources are fossil fuels, coal, petroleum, and natural gas. Carbon is a main element in fossil fuels. Power is work done per unit of time. An example is horsepower, is the amount of work, 550 foot-pounds, performed in 1 second. A watt is unit of power. It's a quantity of work, 1 joule performed in 1 second. Horsepower, being a unit of power, can be equated to a watt. 1 horsepower is equal to 746 watts. These are prefixes. We're all familiar with the giga and the mega. Each one of these prefixes tells how many zeros follow the number. In environmental science, it is the quality of not being harmful to the environment or depleting natural resources, and thereby supports long-term ecological balance. Sustainability is that which meets the needs of the present without compromising the ability of future generations to meet their own needs. Sustainability is that which meets the needs of present without compromising the ability of future generations to meet their own needs. Sustainability meets at the intersection of social, economic, and ecological needs. Another definition is sustainability means using methods, systems, and materials that won't deplete resources or harm natural cycles. A universally accepted definition of sustainability remains elusive because it is expected to achieve many things. Definition of energy efficiency is a percentage of the total energy input to a machine or equipment that is consumed in useful work and not wasted as useless heat. From the engineering standpoint, it is the energy or useful work produced divided by the required energy in. The image expresses it very well. You can see the smaller amount of energy going out and coming in. The difference is the wasted energy. The efficiency C is the energy out divided by the energy in. Here are some examples of renewable energy. Solar, geothermal, and hydropower are but a few examples. The most popular renewable is hydropower. This is a larger view of the preceding slide. Oil and coal are still the largest fuel for energy today. In 2016, the total global energy use from all sources was 151,548 terawatt hours. As there are 8,760 hours per year, this is the energy consumed at the rate of 17.3 terawatts. Solar energy has the potential to supply 3 times the global energy requirements. Wind could supply all the global energy requirements, as well as geothermal. Solar constant is a measurement by satellite to be roughly 1,367 watts per square meter, though it fluctuations by about 6.9% during a year, from 1,412 watts per meter squared in early January to 1,321 watts per meter squared in early July, due to the Earth's varying distance from the Sun and by a few parts per thousand from day to day. Solar constant is the amount of energy that is in a unit time reaches a unit plane surface perpendicular to the Sun's rays outside the Earth's atmosphere when the Earth is at its mean distance from the Sun. It is 1,367 watts per meter squared, or approximately 433 BTUs per hour square foot. The Earth receives solar energy at the rate of about 89 pentawatts. The Earth receives thousands of times the energy from the Sun that the entire world uses. Here shows 5,145 times. This graph shows clearly the extreme increase in energy use since about 1950. King Hubert was an American geologist. He worked for the Shell Research Lab in Houston, Texas. He made several important contributions to geology, geophysics, and petroleum, most notably the Hubert curve and the Hubert peak theory, with important political implications. He was often referred to as Mr. King Hubert or King Hubert. Hubert is best known for his studies on the size of oil fields and natural gas reserves and the limits he's imposed on rates of oil and gas production. He predicted that for an oil-producing area from an oil-producing province, a nation, or a planet as a whole, the rate of petroleum production of the reserve over time would resemble a bell curve. Based on this theory, he presented a paper in 1956 meeting of the American Petroleum Institute in San Antonio, Texas, which predicted that the overall petroleum production would peak in the United States between 1965, which he considered most likely, and 1970, which he considered an upper bound. At first, his prediction received much criticism, for the most part because many other predictions of oil capacity had been made over the preceding half century, but these had usually based on the reserves to production ratio, had not taken into account future discoveries, and had proven false. Hubert became famous when U.S. oil production peaked in 1970 and began to decline as he predicted. This is the Hubert curve. This is history. It clearly shows that Hubert was correct. The United States has not produced oil at a higher rate than it did in about 1970. This is the previous curve with some prediction added on. The anticipated increase is due to hydraulic fracturing or fracking. This prediction has not come to fruition. This graph shows the U.S. oil production and the U.S. imports. The imports currently exceed the production. This photo is included to demonstrate the panic and chaos that ensued as a result of the oil embargoes in the 1970s. A person could buy gas only every other day. Yes, this was the United States. Some say just drill more oil. This graph clearly shows the highest discoveries of oil was in the 1960s and has decreased ever since. The first reason for using renewable is dwindling fossil fuels. Fossil fuels, as the name suggests, are very old. North Sea oil deposits are around 150 million years old, with much of Britain's coal began to form over 300 million years ago. Although humans probably used fossil fuels in ancient times as far back as Iron Age, it was the Industrial Revolution that led to the wide-scale extraction. And in the very short period of time since then, just over 200 years, we've consumed an incredible amount of them, leaving fossil fuels all but gone and the climate seriously impacted. Fossil fuels are an incredibly dense form of energy, and they took millions of years to become so. And when they're gone pretty much forever. There are three types of fossil fuels: oil, gas, and coal. Clearly, our reserves of these are finite. It's a matter of when they run out, not if. Climate change caused by increasing levels of certain gases in the atmosphere is now widely acknowledged as the greatest environmental threat facing the world today. It used to be called global warming, but it's not just about Earth getting warmer. Climate change is about extremes of weather, the hottest, the coldest, the driest, and the wettest weather. It's also about rising sea levels, which will make large parts of Earth uninhabitable. And it's happening already. The 2007 Intergovernmental Panel on Climate Change Assessment report that has conducted beyond any reasonable doubt that the Earth is nearing the stage when carbon dioxide rises will bring irreversible change to the planet. In 1895, this gentleman first calculated the impact of increasing carbon dioxide could have on the Earth's temperature. Since then, scientists have further refined their understanding of the greenhouse effects and the role our rising carbon emissions are having on it. From the first Earth Day in 1970, carbon dioxide in the atmosphere has risen 24%. And because carbon dioxide remains at the atmosphere for centuries, the impact of our emissions today will linger long into the future. Sunshine is a manifestation of solar radiation, and when it is absorbed by the surface of the Earth, the surface heats up and emits a different kind of radiation known as infrared radiation. Carbon dioxide is a special chemical in that it is transparent to solar radiation, and yet it absorbs infrared radiation. Thus, the presence of carbon dioxide in our atmosphere allows sunshine to penetrate to the surface but inhibits the emission of radiation into space. Over the last 800,000 years, atmospheric CO2 levels, as indicated by the ice cores data, have fluctuated between 170 and 300 parts per million by volume, corresponding with conditions of glacial and interglacial periods. The Vostok core indicates very similar trends. Prior to about 450,000 years before present time, atmosphere CO2 levels were always at or below 260 parts per million by volume and reached lowest values approaching 170 parts per million by volume between 660 and 670 years ago. The highest pre-industrial value recorded in 800,000 years of the ice cores recorded was 298.6 in the Vostok core, around 330,000 years ago. Atmospheric CO2 levels have increased markedly in industrial times, measuring in the year 2010 at Cape Grim and the South Pole both indicate values of 386 parts per million by volume and are currently increasing at about 2 parts per million by year. Sea level rise is an indicator that our planet is warming. Much of the world's population lives on or near the coast, and rising seas are something worth watching. Sea level can rise for two reasons, both linked to a warming planet. When ice on land, such as mountain glaciers or the ice sheets of Greenland or Antarctica, melt, that water contributes to sea level rise. And when our oceans get warmer, another indicator of climate change, the water expands, also making sea levels higher. Core samples, tide gauge readings, and most recently satellite measurements tell us that over the past century, the global mean sea level has risen by 4 to 8 inches. However, the annual rate of the rise over the past 20 years has been 0.13 inches per year, roughly twice the average speed of the preceding 80 years. The main cause of such warming is thought to be the greenhouse effect that is majorly in effect due to humans. With an increase in temperature, glaciers worldwide are melting faster than the time taken for new ice layers to form, and sea water is getting hotter and expanding, causing ocean levels to rise. Rivers overflow due to melting glaciers, causing floods. Forest fires are on the rise, and innumerable undesired effects are taking place due to global warming. Global warming applies to the long-term trend of rising average global temperatures. Climate change is a broader term that reflects the fact that carbon pollution does more than just warm our planet. Carbon pollution is causing changes in rain and snow patterns and increasing the risk of intense storms and droughts. The second reason for using renewable energy is global warming. Here are the top countries in the biggest proven oil reserves as reported by EIA, Energy Information Association. Venezuela, proven oil reserves 213 billion barrels. That's 297.6. Total oil supplied in 2012, 1,000 barrels per day. 2,489. Venezuela surpassed Saudi Arabia last year to become the holder of the largest oil reserves in the world. However, annual production of the OPEC supplier is considerably less than the kingdom. Saudi Arabia, proven oil reserves, 267 billion barrels. Total oil supplied in 2012, 11,545. Saudi Arabia has the almost one-fifth of the world's proven oil reserves and ranks as the largest producer and exporter of oil in the world. Canada, 173 billion thousand barrels of oil a day. Canada's oil sands are a significant contributor to the recent growth in the world's liquid fuel supply and comprise a vast majority of the country's proven oil. Iran oil reserves, 154. Oil supply in 2012, 3,538,000 barrels per day. Iraq reserves, 141. Kuwait reserves, 104. United Arab Emirates, 97. Russia, 80. Libya, 48. Nigeria, 37. In 2017, the United States imported approximately 10.1 million barrels per day of petroleum from about 84 countries. Petroleum includes crude oil, natural gas plant liquids, liquid refinery gases, refined petroleum products such as gasoline and diesel oil, and biofuels including ethanol and biodiesel. About 79% of the gross petroleum imports were crude oil. In 2017, the United States exported about 6.3 million barrels per day of petroleum to 180 countries. About 82% of the total petroleum exports were petroleum products. The resulting net imports minus exports of petroleum was about 3.7 million barrels per day. In 2017, the United States consumed a total of 7.26 billion barrels of petroleum products, an average of about 19.88 million barrels per day, imported 10.08 million barrels per day, exported 6.34 million barrels a day, for a net import of 3.73 million barrels a day. This is a net import of about 19% of consumed oil. The U.S. is the largest consumer of oil in the world, burning through 19.88 million barrels per day. Even if the U.S. produced all petroleum products domestically, Americans would still feel the shocks from market volatility. Oil is a global market, and market prices prevail regardless of origin. Despite policies to improve vehicle efficiency, America remains dependent on oil. This dependency presents several threats to the U.S. national security. First, oil price volatility hampers American productivity and consumers. Second, U.S. oil dependency distorts foreign policy. Lastly, oil dependency undermines military preparedness and effectiveness. United States annual production of 7.10 to the 6 billion barrels times 365 days per year is 2.56 times 10 to the 9th billion barrels per year, divided into 25.4 times 10 to the 9th total reserve equals 9.9 years. If there are any questions, please post them on the eLearn help discussion.